So we're going to start the introduction of Snowflake today, and also we'll see AWS part. Okay, the basic stuffs we'll cover today. So yesterday we have understood the cloud computing, isn't it? So
Yeah.
I hope you got the idea about what is cloud computing and what are the services that we can get out of that, and why that is important for today's world, today's growing demand of internet and all the things. How we can take advantage of technologies to a scale or maybe collaborate and do lots of project in real world with lots of advantages. Although there were some cons, but that was very limited as compared to the pros. So that's why. And now coming to Snowflake. So Snowflake is a cloud data warehouse. Okay. So
Mhm.
do you know about the term data warehouse?
Yeah, yeah.
Okay. So the today learning objective will understand the fundamentals of a Snowflake and a Snowflake architecture, and also see the edition and features and the free tier account, the provision that they provided, and what are the features that they provide to the paid account, and also see the web interfaces overview and warehouse and resource monitors. So warehouse, what do you mean by warehouse? Can you tell me? Data
Warehouse
warehouse?
it's a database basically used for business analytics. So creating the reports, visualizations, and everything, so that we can it's easy to retrieve the visualizations and
Yeah,
reports.
visualization is a part of thing that we can perform out of data warehouse, but data warehouse is
Mm.
a kind of place where you store all the things, like,
Mm.
isn't it? The storage part we do and the computation part. So two
Okay.
things we can perform on this data warehouse. One is a storage and second one is computation, and that is on the cloud.
Mhm.
Okay, that is not in our local system. So in very layman terms, we can understand a Snowflake is a cloud based data warehousing platform delivered as a SaaS solution. Do you know SaaS?
Yeah, software service, right? Mm.
So yesterday we have learned about these three applications like SaaS, PaaS, and IaaS.
Yeah.
Okay, so Snowflake is a SaaS solution, means it's providing a software as a solution. Okay, so it's a cloud-based data warehouse platform, and it allows users to efficiently store, process, and analyze massive amount of data sets. Fine, and a Snowflake's architecture separate a store and compute engine. So we will understand this, in very depth manner when we will performing the practical implementation, how this is important and why
Mhm.
this is the main thing that separate a Snowflake from the traditional data warehouse systems, because the
Okay.
compute engine is separate and a storage engine is separate, so the load is perfectly distributed across the servers. Okay, so it enables a scalability and flexibility. All data is automatically encrypted and micro partitioned for the efficient access. We don't need to worry about the encryption of the database. It is automatically encrypted inside the a Snowflake. So the pre-written code is there for the system. So the thing is, like, we have to perform our application only all the features that is happening on the background, because it's a software as a service platform, and it is on also on the same link, means the only link we have to access. We don't need to download anything. In cloud computing, this is the main advantage now. We don't need to update, we don't need to download any package. Everything is available on that particular link, means URL, isn't it? Understanding what I'm saying?
Yes, I think.
Okay, fine. So compute is provisioned as independent virtual warehouse. So fine. So supported platforms are three majorly. I've already shared this with previous class, like Amazon Web Services, Google Cloud Platform, and Microsoft Azure. Three cloud providers are there. So the difference between a Snowflake and traditional data warehouses are majorly categorized in four parts. One is architecture and flexibility. So you can see in a Snowflake, it is cloud native. Cloud native means everything will happen on the cloud. Okay, and cloud means on the server by the help of internet, means the URL with link we have to access, and we can perform all the things on that particular URL only. We don't need to download any package or install any updates on that. Everything will be automatically done by the company itself, and that will be reflected on the cloud platform. So it is cloud native and multi-cluster. But traditional database are where on premises tightly integrated as storage and compute, because it was happen only on the local system now. So it is limited. Storage was also limited, and all the things were very much saturated. So flexibility is there. And setup and maintenance, Snowflake is fully managed SaaS, zero maintenance. We don't need to worry about any update packages. Everything is automatically managed by the system itself. But the traditional database, where have to complex setups like manual administration required, on all the things were done by manually. So maintenance was difficult in that. A scalability, a Snowflake has auto scaling type of feature. Okay, so elastic compute and instant resizing. Do you understand what is auto scaling?
Yeah, whenever the demand is more, the servers keeps on increasing. When the demand is low, the servers keep on
Correct.
reducing less.
So just I'm giving you one example. Let's suppose you have a system. Maybe this. You have a system, and your system does not know how much users have there, uh, who are going to use that system, means your website. Let's suppose you have taken a thought of maybe 10,000 people will going to hit the server. Okay, so you have bought the system architecture according to the 10,000 users, like the storage, the capacity, the load balancer, all the things. But actually, what happens? The users' demand will automatically increases instantly, and it becomes like 1 lakhs. Okay, so your system was not supposed to meant for this particular user, means crowd. So what will happen? It will auto scale itself based upon the capacity. It will auto scale, and that will happen only because your system is deployed on this kind of platform, as Snowflake and all the things are responsible for scaling all the things, so that your system will not hit any kind of you know uh, what we can say, deadlock, or maybe the breakdown of the failure of the system, isn't it? So auto
Yeah,
scaling means increasing the capacity based upon, let's suppose 10,000 users were there to create their account. So maybe 1 TB of 1 TB is also greater, 1 GB of database where 1 GB of storage were required, but instantly 1 lakh user were uh, come to your platform to register. So maybe 10 TB of 10 GB of storage is required. So you don't need to do any kind of manual operations to change this storage. You just only need to set up facilities on a Snowflake, so that the system can automatically scale itself based upon the demand. Got it?
yeah,
So this is auto scaling, but in traditional databases we will have to do manual scaling. Hardware limited requires downtime, and a storage and compute. So the a Snowflake has separate a storage and compute engine, scales independently, and but in traditional databases it was coupled. A scaling affects both. So what I mean by a storage and compute engine were separate, means every data has their own compute engine. So the load is perfectly separated, and we don't need to worry about the time, and everything is happening in the parallel time. Like 10 minutes is required to process this part, so 10 minutes also required, 10 minutes also required. So all the process will be completed within 10 minutes. It's like parallel processing also can happen on this particular thing. Okay, so it helps in many types of application. And now coming to the difference between data format support. So a Snowflake supports structured and semi-structured data. Okay, like JSON and Parquet is, JSON and Parquet format of data sets.
yeah,
Okay, so it's a like JSON is like very simple key value pair. Okay, like you have key and value. Parquet is also kind of semi-structured databases, which is helpful to supportive for the Snowflake. And traditional databases were used to be for the structured data sets only, like relational databases we used to make. And performance and concurrency, Snowflake has high concurrency with multi-cluster compute. In traditional databases, performance drops with more concurrent users. Okay, and data sharing in Snowflake, real-time data sharing can happen, secure and zero copy data sharing. But in traditional databases, data must be copied or exported by ETL. Export trans uh, what is the full form? Export, transport, and load, now
yeah,
ETL, yeah. So pricing model is pay as you go, as I already told you this. And in traditional, that's were fixed and license based on the capacity based. You have to pre-plan like how much you were going to use. So it was fixed and all the things. But in this, pay as you go services is available. Now coming to the features of a Snowflake. So the very useful feature of a Snowflake is like one of the features is time travel. Allow users to access historical data up to 90 days. So we can restore the data that was deleted or modified accidentally. Okay. So you have 90 days of recovery time to recover any type of failure or maybe deleted data which was accidentally deleted. So that is a feature you can use. And zero copy cloning means it's create instant metadata, only clones of table, schemas, or entire databases. Okay. So it happens in the background, like when you have stored something in your databases, the system makes multiple, at least three, copy of that, because if something is stored in any kind of system, maybe in the maybe in the Snowflake type of system, which is a cloud data warehouse system, so it is also a part of hardware. Now your data is stored in some kind of hardware inside any server, which was way means very much at long distance from you, like you are sitting at India, and maybe your system was in your cloud platform is storing all the things in Dubai. So the distance is very much high, but the system is stored in any kind of hardware. So there is also kind of failure type of thing can happen, isn't it? Because that's also
Mm.
hardware now. So that's why the system replicates that data in multiple, at least three copy of the data, so that in case of failure of this one, we can go to any different places where the same data is replicated and perform the task that is being asked with by the user. So, do you have any idea about master and slave node architecture? Master and slave architecture.
Yeah, I know.
So, you know how data node and name node work?
It's been a while since I read those things, but then I read those things.
So, if you have some, vague understanding about this, you can also relate my words. Like there were some one name node. Okay, name node was the head node, and data node was there. Okay, and every node has at least two same data node in one block, and multiple data nodes were there. And getting my point, what I'm saying. Have you studied
Yeah,
this same thing in
yeah,
Hadoop?
yeah, yeah.
So that's
Yeah, Hadoop, I know.
yeah, Hadoop architecture. This is happening. So this type of thing happens. So same in Snowflake also, the replication of data happens in that kind of manner. So that is a different kind of architecture, like name node data master slave architecture. So we don't need to worry about the background architecture. We just need to understand the thing happen in this, like zero copy cloning. It creates instant metadata, only clones of tables, a schema, or entire databases. So no additional storage cost initially, since data isn't physically duplicated. So secure data sharing is share data in real time with other Snowflake users without moving or copying data. The very much advantage of this cloud system is, like, when I have created a drive on my Google Drive, isn't it? And I have stored some PDF and I have given access to you, isn't it? I've given
Mm.
access to you my drive, and maybe that drive have 1 GB of data. I don't need to share this 1 GB to your local system. I just stored this in a particular space and given the access to you, and I can also access, you can also access, and maybe different user can also access. So there are multiple users can access to the same a space, isn't it? So that is very much cost effective actually. But previously, when this type of technology was not there, we need to share all the things manually in the hard disk. Like 1 GB data is here, and we need to copy this in another hard disk, and that user can only access to this because there were no any cloud technology. So in a Snowflake also, if something can be accessed, something like application is there, we can assign the role to the users, we can assign the responsibilities and all the things in real time. Okay, with other users, without moving or copying data, they can access to the same places because everything is happening on the cloud platform. Okay, so like the cloud computing services, it's also a SaaS application, so all the features are similar with the cloud computing technology. Like it enables collaboration across organizations securely and efficiently. Okay, so pay as you go model is there for compute and storage. The payment system is like $5 for every TB, $5 per TB they charge. Okay, for enterprise level, or maybe the costing is for the compute engine. A storage is very much affordable. $5 per TB is not that much high, but the compute engine is costly in a Snowflake. So we'll see that also. But you have I think you have already created your Snowflake account now.
Yeah, I created my Snowflake account.
$400 limit you were shown there. $400 you have given by the Snowflake account, isn't it?
Yeah.
So we can easily utilize that, but that amount for our project also for learning purpose, that is sufficient. And now coming to the Snowflake architecture. So a Snowflake architecture is mainly divided in three layers. One is cloud service, another is uh, cloud sorry compute virtual warehouse, and third one is a storage layer. So base layer is a storage databases, and the second layer is compute virtual warehouse, and the top layer is cloud services compilation and management. And you can see here the second thing is meta data key value store foundation DB. Okay, so what you are understanding by seeing this architecture, can you explain?
Hmm. Basically, authentication is going on through Snowflake. That
Yeah,
is why login.
there are things you can just read and try to understand it. This is very much well defined. You can see authentication and access control is there.
Yeah.
Okay, the first top layer means everyone have to sign up and see what kind of role and responsibility they can access to the database. Okay, the base layer is
Okay.
database, no? So first thing is authentication and access control. Second layer is like infrastructure manager, optimizer, transaction manager, and security. Okay, so these all are the things on the top layer, like cloud service and compilation management, that we see as a user on the interface. Like this is something that we see on the user interface, and this is something that is responsible for doing all the computational part, like making clusters, making storage and compute engine separate, and replicating the databases in different uh, different storing data into different files, so that in kind of any kind of failure it can be easily replicated and extracted out of that. So all the things is happening by this metadata key stored foundational DB, and optimizer is there, and transaction manager and security is there. So try to see this figure and try to understand and explain me what you are getting out of this.
Basically, we are following the to access the database, right? So we are using the uh, three-layer architecture. Using
Correct.
one is the one is through the authentication access control. So
Yeah.
from then onwards, we'll get the metadata key value store.
Correct.
From metadata key value store to computate virtual warehouses.
Yeah.
From there onwards, we are accessing the storage databases.
Correct. Correct. So you can say that this cloud service is the brain of the whole system. This is the brain which is responsible for allocating all the things, managing all the things, and this is the a storage part, the hardware. And this is the
Yeah.
compute virtual warehouse where all the computation is happening. You can see virtual warehouse, and every I have already shared with you, every compute and a storage are separated now. So this is compute engine. So you can see each warehouse has separate compute engine, isn't it? Each warehouse has its own compute engine, so the load is perfectly distributed, and this is the brain who is responsible for this, and this is the main databases where all the data is stored. So three layer architecture follows by the Snowflake. So this is the main thing. Okay, so get a clear picture out of this, so that this will help you to further understand the topics in more detail way. Is it fine now?
Yeah.
So one question, what do you mean by zero copy cloning? I have just explained you
Zero copy cloning basically is to
this one.
create instant metadata clone the tables for a concentration data display duplicated. Okay. Okay.
See here, this can be asked in interview also. Okay, although it's
Okay.
not very difficult thing, but you can refer this Snowflake documentation as well. Okay,
Okay.
for reading all the types of thing. Here you can see. Clone a statement for most object. Do not copy grant on the source object. to the object clone. However, create command that support all the things. So here you can see everything is perfectly explained, and
Mhm.
you already know SQL now, so everything
Yeah.
alter table and all the things you can easily see. And most of the things are related to SQL query only, because while we are performing any
Mhm.
task, we have to write SQL query. So alter command, there were four types of in SQL queries like DML, DDL, DCL, and DCL. Do you have idea about these type of things?
Yeah, DDL email comments I know. Yeah. Mm.
Data manipulation. So alter will fall into which category?
Alter. It's a DDL.
It's DDL.
Yeah. Select, update, delete, alter. No. So
No, no.
no, 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 no.
Alter is like for
No, no, no. Alter
manipulation.
will come in DML.
Yeah, correct. It's in DML. Okay. So
Mm.
zero copy cloning. This one is happening. Zero copy cloning means it create instant metadata. Means
Mm.
it create instant metadata only clones of tables, schemas, or entire databases. Okay. So no additional storage cost initially since data isn't physically duplicated. Understanding what is the meaning of physically duplicated, I have given the example of Google Drive now. Like
Yeah.
a single places, access will be shared to the user, multiple users, not the data is replicated every time, isn't it? Data is stored in the only one place, no physical duplication is happening, only the accessibility is enhancing, like increasing. Okay, so you can also follow this documentation for your work also. Maybe if you wanted to do some kind of thing, so you can easily refer to this website and see. And lots of things we will also cover in our session as well, like project and thing. Okay, so you don't need to worry about this right now. We'll see all the things, data loading and features. So how to load data into Snowflake, you can see here. All the commands and work with S3 compatible storage. S3 full form is
S3 is S3
what the
full.
full form of S3. S3 means SSS. So it's the full form is simple storage service. Okay,
Okay. Mm-hmm.
simple storage service we say in short form S3.
Mm.
So fine it is. So you can see all the things, and you can refer to this website. Actually, I've
Okay.
also used this website for learning as well. So it's the a Snowflake company has own created this documentation. So you can see this for understanding all the concepts. You can also see the vendor support S3 compatible. All the companies who are using a Snowflake. You can see
Mm-hmm.
Backed, Brave, Cloudflare. So one of the big tech company. Every you know OpenAI, even OpenAI is using Cloudflare, and they are using a
Okay.
Snowflake. So you can see that how much demanding technology is this. Future, upcoming future, Snowflake demand is increasing. So the skill set that you are acquiring here will help you in the future jobs as well. Nutanix, NetApp, these are the big tech. Okay, so Hitachi, these all our companies are using Snowflake technology. So query data, all the things you can see, and we will also see in our project as well, so how to do and how to perform all these queries and all. So fine it is. So now coming to our topic again, architecture. I hope you got the big understanding of this architecture, like three layer
Yeah.
for the Snowflake is happening, and cloud service layer. So the cloud service layer is the entry point for all interactions a user will have with the Snowflake. Okay, it acts as the brain of a Snowflake or coordination all activities. So I've told you this is a cloud service, and this is actually happening. This acts as a brain of the Snowflake, because everything is like metadata storage, infrastructure management, transaction optimization, access control. Everything is managing out of this layer, isn't it? So you can say this is the brain of the layer. A Snowflake, three layers. One layer is cloud service, which is acting as a brain. Now query processing layer. So you can see one very interesting thing, like a Snowflake uses t-shirt size for the storage of their data values. Okay, it's like
Mm-hmm.
extra small, a small, large. So they use this naming convention actually in their company to denote all the things, like how much size of your database is. Okay, so that is representing by the t-shirt size names. Fine. Is my voice is clear to you?
Yeah, it's clear only.
It is not slow. No, no, it's okay. It's fine, no?
No,
Audible?
no, no, it's not slow. It's fine only.
Okay, fine. So you can see query processing layer is there. So after a given query has passed through the cloud services, it is sent to the compute layer for execution. And you have already executed query on a Snowflake. So I hope that you have understanding about how to run this query, isn't it?
Yeah.
We have performed the CSV file project now.
Yes, yes.
Okay. So every query that you execute there, that has been passed through cloud services and it is sent to the compute layer for execution. Okay. And compute layer, what do you mean by compute layer?
Not sure, I think.
Compute layer is like computational part of the thing, like where all the things are computed. You know, CPU, GPU, all the things are there now.
Yeah, yeah, yeah.
So SQL is computed by, there is a compute layer, you can understand this. Okay. Not
Okay,
going to the much because that is very much architecture level of understanding. Okay, so that is not
okay.
much required. So you just only have to understand like after passing every query, it is sent to the compute layer. Compute layer is some thing that is responsible for executing the query, means understanding the meaning out of the query and performing the operation. Like, uh, let me explain you a little bit about this compute layer. So maybe compiler, you know, na compiler.
Mm,
So how compiler works? Like you written some code in Python, maybe hello world, print hello
mm,
world. So how this compiler understand that you wanted to print hello world? Because print is already defined in the keyword. So lexical analysis, all the things happen inside that compiler. Compilation we used to say lexical analysis and tokenization, all the things. 7 layers are there for compiler design. If you will
mm,
study this type of thing, so compiler design have 7 layers. So 7 layers after passing all the things, then a compiler give the output like this code wanted to print hello world. Okay. So as same
mm.
with the SQL query, the compute engine is responsible for understanding the SQL query and printing the thing that is required out of that query. Okay. Like which join you wanted to perform, which thing is like that way. So the query processing in a Snowflake execute query using virtual warehouse, which are compute clusters. It provide the processing power for data manipulation and retrieval. Okay. And an important aspects of Snowflake design is that the node in each running warehouse are not used anywhere else. Getting this point? Just read it again. Try to understand this line.
Okay.
So when I have told you like storage and compute are separated, can you relate this line with this point?
The nodes in each running warehouse are not used anywhere. So if particular node is being used in any warehouse, so
Yeah,
that is not being used anywhere else.
correct, correct, correct. So this is the main aspect of Snowflake design. Okay.
Okay.
So where the nodes are running that is not used for anywhere else, means that particular node is running for only single. So this will help us to perform the computationally fast. Like this is the node we are running all the computation of this data. So this is only responsible for this one, and every storage maybe different storage, different data has different nodes. So like this type of thing separated from each other. Fine. So this node will not be used anywhere else. It will only happen after the completion of this particular data. So it will be free and then it can be assigned with other nodes. So compute engine is there. So compute engine is responsible for computing. You can understand this by this way. Maybe data is there. We need to process this much amount of data. Okay. So data are coming in the chunks. So data processing, how it is happening. This is the compute engine, maybe 4 to 5 compute engine. So right now this is performing inside this compute engine. So after completion of this processing, then this node will free, and then this again this come. Okay. So everything is assigned by the node, and all the compute engine is happening by that particular layer, cloud layer. Okay. Compute layer, the one this one, cloud service layer. Okay. Getting the thing, like how the things are happening.
Yes, I think.
So that is the thing, like the nodes that is running running warehouse are not used anywhere else. So now coming to this point, database a storage layer. So a Snowflake database a storage layer store all data in columnar format. Okay, and in traditional databases, the storage were in the row format, but in the Snowflake database storage, all the data is stored in columnar format, organized into micro partitions, and this layer is scalable, secure, and optimized for analytical queries. Fine. So the centralized scalable storage, all data in a Snowflake is stored in a centralized location on cloud services like AWS S3, Azure Blob Storage, or Google Cloud Storage. Okay, and it's automatically partitioned and compressed. So centralized storage is there. Columnar format means data is stored in optimized columnar format, making it efficient for analytical querying and reducing a storage cost. Fine. And separation of storage and compute. Unlike traditional databases, a Snowflake separate a storage from compute. This means multiple data virtual warehouse can query the same data without conflict. Okay. Automatic data management. A Snowflake handles indexing, metadata compression, and partition automatically. So users don't have to manage this manually. So all the things are happening automatically. Zero copy cloning and time travel. Using metadata, Snowflake support features like time travel. Up to 90 days, we can fetch recover our data in case of any um, failure of deletion, or maybe by mistakenly deleted the data, we can easily extract that data within 90 days. And cloning, it create copy of databases without duplicating data physically. Okay, so now coming to the next part, Snowflake caching. So do you know about cache memory?
Cache memory.
Cache memory means, let's suppose, just I'm giving you example, this is your web page. Okay, front end is there and back end code is there, and this is your database from where all the things are coming. So let's suppose you have written anything on front end. Maybe you wanted to get some data out of this website. So this will send the API means application programmable interface. API call will get hit to the database, and it will send the data, whatever the data that user has asked from the databases, and it will reflect to the user. So in the first time, let's suppose it happen, you can relate within everything, like in SQL query you can also relate. I'm just giving an example of front end back end web page. So at the first time when the user demanded that particular data, maybe it took 10 seconds to retrieve that data. So that will be stored now in the cache memory. Okay, for 24 hours it will be stored in the cache memory. Cache memory means in your local system it will be stored. The web page that ask for your local system, that a storage will be there, and in JSON file format, or maybe in different file format, that is stored for 24 hours. So in case you will again hit the same thing that you wanted to ask from that particular website, so despite of going to the backend databases, it will simply check that whether it is available in the cache memory or not. So if this is available, it will simply show you the output. Means you don't need to hit the server again and again. So it will reduce the cost of the API. Okay. So this is like storing something in the cache memory help us to balance the load between the server. Getting my point?
Yeah.
So cache memory means it's a kind of memory that is stored in the local database, local computer, out of the server. Like data came out from the server and stored in the cache memory for a while, and after some time it will automatically be deleted. So here you can see it holds the result of every query executed in the past 24 hours. So every query that you will perform on the Snowflake, that will be hold for the 24 hours. So in case you will again ask for the same, let's suppose you run a query on a Snowflake, and your first query took 150 seconds to execute on a Snowflake. So at the second time when you will run the same query, so it will only take took 30 seconds. How this is happening? Because at the first time when the data came out of the database storage, so it stored in the cache memory for the 24 hours, And if second time if the users again ask for the same result of the query, same query will again run to that platform. So it only took 30 seconds. Got it? So all the things are available on this particular thing. Metadata cache means stores metadata information about tables, views, and databases. Local disk cache, you can see remote disk, local disk cache, and result cache, and a Snowflake users are there. So all the things are managed on the background itself. Whenever a virtual warehouse retrieves data from the table, it creates local cache containing that data. Subsequent query have the option to reuse this cache data. Okay. Subsequent queries have the option to reuse this cache data. Getting this point?
Mm.
Karthik, can you tell me if you have any doubt you can ask?
So basically, whenever you're executing the queries, right? So it will be basically stored in the cache memory, so we can reuse the queries
Correct.
from 24 hours.
Yeah, perfect. So this is that. And metadata, so see,
Mm.
metadata means like, see, one thing is your data actually. There are two types of thing. One is data actually, and second is metadata. First thing is
Mm.
data, and second one is metadata. So I'm just giving you example. When we create a full stack application, what we used to do, you have heard about MongoDB.
Yeah, no column database.
Yeah, it's a NoSQL databases. So
Mm.
I've created a website of where I've created a website of mochiudan.com. This one website. So I can show you. This is our client website, Mochiudan. Maybe not like this. So leave that also. So just I'm giving you example. I'm not wasting time on that. So just I'm giving you example. Let's suppose that website contains lots of images on the platform. Okay. So one thing is actually that particular data means images are the data. Fine. So images are somewhere stored in the database. You are showing that particular image in the front end, but that is coming from the back end, na database, na that image is
Yeah,
stored in the database. So that is actually data present in the database. But the second thing is metadata, information about that data, that where that if that image is stored, that image is stored in some kind of address, like maybe that image is stored in hash is to maybe the pointer address or whatever the storage will be there, isn't it? Like one is the data itself, and second thing is the address where the data is stored, isn't it? So in terms like one is the book in the library, book is also a data, and second is where that book is kept. Like that book is of mathematics, so mathematics book has separate column of mathematics area. So that is the metadata, means information about the data, where data is actually stored, isn't it? One is actually data and second is metadata, means information about the data, like where your data is stored. So in terms of this kind of thing, like when your website contains lots of images, you have images which is stored in the data, but you have information about that data, like where that image is stored. So that is called metadata, and that is stored in the MongoDB. And API hit this API hit this NoSQL databases, and it actually go to this particular address, like this images will found at this particular address, and then this intersection of the communication happened. Okay, so that is the thing. Here you can see metadata cache. Metadata cache stores the metadata information about table, views, and databases. Like one thing is actually data that you are actually asking, and second thing is like where your data is stored. So it is like stores like information about the tables, views, and other things that is available. Okay, and local disk caches. Whenever a virtual warehouse retrieve data from the table, it create a local cache containing that data, so that the subsequent queries have the option to reuse this cache data. Fine. It also help us to reduce the time of the subsequent query, because we can connect with the previous one, isn't it? Like if previous query was related to that particular query, so in the subsequent query we can also utilize that particular data in order to reduce the cost of fetching the data again and again from the server. So these all are the things. Now coming to the, so you can share your screen and I will tell you about something on the AWS part first and Snowflake. show you. I wanted to see that whether you have created your account or not. Just stopping my screen.
Yeah, I created this one.